Okay, let's solve some equations, some rational equations. Remember what we have to do. We have to find the restricted values, then the LCM, and multiply. Whoops, and you can't see that. Then solve, and then check. Okay, so that's what our process is. All right, so the restricted values, which I'm going to abbreviate RV, are any values that make the denominator 0. Well, the only value that will make any of the denominators equal to 0 is if x is 0. Now, for the least common multiple, x is just equal to x. 4 is equal to 2 times 2. And 2x is equal to 2 times x. So the least common multiple, or least common denominator, has to have a factor of x, a factor of 2, and a factor of 2, which gives us 4x. So I'm going to take my original equation and I'm going to multiply each term times 4x. Okay. Now the whole point of doing this is to clear the fractions, to get rid of the denominators. So if that doesn't happen, then there's a problem. So here the x's cancel, and I'm left with 20. Here the 4's cancel, so I'm left with 7x. Here the x's cancel. 4 is the same thing as 2 times 2, which means one of the 2's cancel. So here I'm just left with 6. And now I solve this. So I'm going to subtract 20 from both sides. That gives me 7x is equal to negative 14. When I divide by 7, I get that x is equal to negative 2. Now to check it, I would just do this in my calculator. Okay, so I want to see if x is negative 2, this is a true statement. So I'm going to clear my calculator, and I'm going to put in 5 divided by negative 2 plus 7 divided by 4, and that equals negative 0.75. Well, the right side is equal to 3 divided by 2 times negative 2, and I get negative 0.75. So both sides are the same, so it checks. And it is not a restricted value, so I've checked against that. Okay. All right, 37 is the same thing. For the restricted value, the only value that will make a denominator equal to 0 is if x is 0. I hope we can tell at this point that my least common multiple is 3x. It has to have a factor of 3, and it has to have a factor of x. So I'm going to take each of these 3 terms and multiply them by 3x. 3x over 1, 3x over 1, and just 3x. Again, the whole point of this is to clear the fractions, so if you have a fraction left, then something is amiss. Okay, here the x is canceled, so this gives you 15. I have a 3x numerator and denominator equals 10 plus 3x. So I've cleared the fractions. I've done everything correct so far. So now I just need to solve. So I'll subtract 10 from both sides. That gives me 5 is equal to 3x. When I divide by 3, I get that x is equal to 5/3. Okay. I check it against my restricted value. It's okay. And then to check it again, I would just plug it in and make sure that the sides are equal. Okay, so for 38, the restricted value, x is 0. If x is 0, it makes this term undefined, so the whole thing is undefined. And there's only one element in my denominator, so my LCM is just x. So I'm going to take each term in here and multiply it by x, my least common multiple. So this gives me x squared, here the x's cancel, plus 12 is equal to negative 7x. Now I notice that this one is different. This one is a quadratic, so I can't get the x by itself. I have to set it equal to 0 and factor. So I'm going to add 7x to both sides, and I'm going to write my answer in descending order. So I have x squared plus 7x plus 12 is equal to 0. So this is a trinomial, a leading coefficient of 1, so I know to factor it I have to look for two numbers whose product is 12 and whose sum is 7, and they are 3 and 4. So this factors into x plus 3 times x plus 4 and equals 0. Using the zero product principle, that means if the product is 0, then either x plus 3 is 0 or x plus 4 is 0. So here x is negative 3 and here x is negative 4. Okay, so I've checked them against my restricted values. That's good. So now I just want to check them for accuracy. Okay, so I can do this pretty quickly. I want to know if for negative 3, so let's see if negative 3 plus 12 divided by negative 3 is equal to negative 7. Negative 3 plus negative 4 is negative 7, so this one checks. I'm going to do the same thing for negative 4. Negative 4 plus 12 over negative 4, I want to know if that's equal to negative 7. Negative 4 plus negative 3 is equal to negative 7, so it also checks. Okay, this one is almost identical to this one. Restricted value, x equals 0. The only value that makes a denominator 0 is 0. And my LCM is just x. That's my only denominator. So I'm going to take x minus 8 over x equals 2 and multiply each of those by my LCM. So that gives me x squared minus 8 is equal to 2x. Once again, I've got a quadratic, so I'm going to have to set it equal to 0 and factor. So I get x squared minus 2x minus 8 is 0. Just like the other one, the leading coefficient is 1. I have to find two numbers whose product is negative 8 and whose sum is negative 2. They are negative 4 and 2, so this is x minus 4, x plus 2. So either x minus 4 equals 0 or x plus 2 is equal to 0. So x is 4, x is negative 2. Okay. All right, so I check them against my restricted values. They're okay. So now I check for accuracy. So 4 minus 8 over 4 is equal to 2. 4 minus 2 is 2, so this one checks. 2 minus, negative 2 minus 8 over negative 2 is equal to 2. So this is negative 2 plus 4 is equal to 2, so this one also checks. Okay, our next one here. Let's see. Now I have a binomial as a denominator. So for my restricted values, x plus 8, if it equals 0, then it is undefined. So this means x equals negative 8 is a restricted value. And also, for here, if x equals 0, so I have two restricted values on this. My LCM, I'm hopeful we can tell at this point it has to have a factor of x and a factor of x plus 8. So this is what I multiply both sides of the equation by. So 2 over x plus 8 equals 4 over x. And I'm going to multiply times x plus 8 over 1 times x plus 8 over 1. Now your denominator should cancel out here. So I have a factor of x plus 8 over x plus 8. So this side gives me 2x. My x cancels out, equals 4 times x plus 8. So that gives me 2x is equal to 4x plus 32. This is linear, so I can get the x by itself. So I have negative 2x is equal to 32. And when I divide by negative 2, I get x equals negative 16. Okay, I check it against my restricted values. They're okay. And if I plug it in, it works. So this gives you 2 over negative 8, which is negative 1/4. This gives you 4 over negative 16, which is also negative 1/4. Okay, on 41, for my restricted values, x minus 1 equals 0 means that if x is 1, that's undefined. So that's the only one I have. And my least common multiple has to have a factor of 5 and a factor of x minus 1. So I'm going to take 6 over x minus 1 equals 2 over 5, and I'm going to multiply both of them times 5 times x minus 1 times 5 times x minus 1. Excuse me. All right, so I have an x minus 1 that cancels. So I get 6 is equal to 2 times x minus 1. Okay, so 6 is equal to 2x minus 2. If I add 2 to both sides, I get 8 is equal to 2x. And I finally get that x is 4. Uh-oh, what have I done wrong here? Oh, 6 times 5 is 30. So this is 32. Whoops. And I was just doing some checking in my head, which is how I knew that that was incorrect, that I had made a mistake. Okay, so 6 over 15 does reduce to 2/5, so that's correct. It is not a restricted value, so I'm good to go. Okay, let's find the values in similar figures. That means the corresponding sides are proportional. So the relationship of x to 9 is the same as the relationship of 12 to 8. So I can say that x over 9 is equal to 12 over 8. Okay. So now to solve this one, I can just cross multiply. So that gives me 8x and 9 times 12 is 108. When I divide by 8, I get x is 13.5. All right, now I write it up here. Since 12 is bigger than 8, this has to be bigger than 9. So it makes sense. Okay, again, these are similar figures, so I know the corresponding sides are proportional. So these ratios are going to be equal. So I know that 6 over 15 is equal to, 6 over 15 is equal to x over 27. So when I cross multiply, I get 15x is equal to 27 times 6, which is 162. Now, just thinking about this, I know that this is quite a bit smaller than this, so my x should be quite a bit smaller than 27. Just thinking about it as I'm doing this. So 162 divided by 15 gives me 10.8. And that looks reasonable. Okay, so if I am looking at an application problem, I have to zoom out so we can see the whole thing. So if a horticulturist found that 175 of 1,500 seedlings in an experiment did not germinate, how many seedlings would you expect to not germinate in a batch of 17,000 seedlings? Okay, so I'm going to compare the not germinate to the number of seedlings. Well, I know that 175 did not germinate out of 1,500 seedlings. So 175 over 1,500. Okay, so they want to know how many seedlings would not germinate, so that's going to be my x, out of a batch of 17,000. So once again, I'm going to cross multiply. I have 1,500x is equal to 175 times 17,000. And I get, oh, a big number, 2,975,000. Thank goodness for calculators. So I'm going to divide both sides by 1,500. And I get x is equal to 19, which I would round to 1983. Okay, if 8 ounces of guacamole will serve 11 people, not 11 people, I know. How many ounces of guacamole are needed to serve 80 people? Okay, so we're going to be comparing the ounces to the number of people. So I know that 8 ounces will serve 11 people. So I have 8 over 11. Okay, so now we want to know how many ounces, so that's going to be my x, and I've got 80 people. Okay, so let's cross multiply, so I have 11x is 640. When I divide by 11, let's see, 640 divided by 11, I get 58.2, or I'll just say 58. We will end here and pick up with systems in our next video.